Part 2. The audiogram again. The normal thresholds are lying between -10 dB hearing loss to 20 dB hearing loss for all frequencies. The hearing loss is increasing for elder people. There's example of a typical audiogram from an older adult with age-related hearing loss. There's about 70 decibel SPL at 8,000 Hz. Measured with earphones, so-called air conduction. Cross is left ear and circles are right ear. The audiogram can diagnose different types of hearing loss from patterns of audiogram. Audiogram is still good standard. Pure tone audiometry is most common hearing test. Then we have the categorizing hearing test, like hearing loss, based on the audiogram configuration, symmetrical or asymmetrical, uni or bilateral, progressive or sudden, degree. The degree could be mild, moderate, severe, or normal. Type could be conductive, sensorineural, and mixed. We have two types of hearing loss type: conductive in the outer ear and onto the middle ear from outer and middle ear. And then we have sensorineural is from the inner ear, cochlea, and also auditory nervous system. It's called sensorineural. Conductive hearing loss is reduced transmission of sound to cochlea, can diagnose using otoscopy and tympanometry. How about the audiogram? On the graph there is an airborne gap. The right ear is unmasked and the left ear is unmasked, and you can say the right ear, right ear have a higher level, have a hearing loss bigger than from the left ear. So we have some masked. We have some left bone also, and and some right bone masked. Left bone and right bone masked. Okay, now I understand. And the left bone level and the left ear level are the same, and higher than the right ear. So there is an air bone gap. Yeah. Symmetrical sensorineural hearing loss. It can happen that the hearing loss level is increasing by frequencies more than 20 dB hearing loss, and it's a bilateral sensorineural hearing loss. It is when the right ear and left ear unmasked, and the right bone and left bone have the same. There are no deviation from the values at a certain frequencies. Then we can have asymmetric sensorineural hearing loss. We have an example of unilateral sensorineural hearing loss, left ear. We have a left ear unmasked and left bone masked. Okay. Yes. And then there is no air bone gap. Yeah. Okay. And we have some left ear masked and some left bone masked. The right ear is less hearing loss, less hearing loss, and the right bone, right ear and right bone are almost having the same values, not much hearing loss. So we conclude here that there is a unilateral sensorineural hearing loss at left ear. Yeah. Okay. Newborns. How can we test if their ears are healthy? What objective test can we use? We can use otoacoustic emissions (OAE) or auditory brain response (ABR). Otoacoustic systems and OAE is a sound that is generated from within the inner ear. Okay, from the inner ear. From an OAE screening, a probe is placed inside the baby's ear canal, tones or clicks are played, and the presence of a generated sound in response is recorded. We can talk about intermodulation distortion, some frequencies nearby each other, 1800 Hz and 2000 Hz. Then some intermodulation distortion can happen. They add low and high frequency components. Intermodulation. We can have two. F1 is 1800 and F2 is 2000 Hz. Then we can have two F1 minus F2, that is 600 Hz. We can also have a 1600 Hz, 1600 Hz. We can also have two F2 minus F1, that is 2200 Hz. 1600 and 2200 Hz is between those. F1 equal to 1800 and F2 is to 2000 Hz. Yeah. Compression, rectification. Yeah. Auditory brain response. Present repeated clicks. Measure potentials on scalp EEG. Okay. EEG signal is response to clicks plus noise. Average sweeps to reduce noise. Two most common causes of hearing loss: aging and noise. And again, we have this audiogram for hearing loss due to age. 20 years old, normally hearing people has no hearing loss, and the decibel hearing loss is increasing for when the time is growing. 70 years old, you get a 60 dBs hearing loss. I got 80. Common complaint: I can hear you, but I don't understand. Stop mumbling. Yeah. And noise-induced hearing loss. What does that mean? It's for everybody. When noise-induced hearing loss. Okay. If you have, there's a notch at about 4 kilohertz, 4000 hertz. So the hearing loss is greatest for all ages 20, and there's a dip there. And maybe why explain this? Maybe because of the resonance frequency. 4000 hertz is almost the same as the resonance frequency in the ear channel. Maybe, I guess. Hearing thresholds again. A transfer function of a combination of outer and middle ear. There is a transfer function. We have some frequency, first axis, logarithmic build up from 100 to more than 10,000 hertz, and there's a dB decibel from minus 15 up to 10, almost transfer function of combination of outer and middle ear. Outer and middle ear, okay. And we can have define L index EQ and LEX. The principle is to use total or average energy. LEQ is equivalent steady sound level energy average over time. Equivalent steady sound level energy average over time. LEX, that's sound level that over an 8-hour period provides the same energy. What is the limit of safe? LEX about we say it is 85 dBA. What is if the levels are over the limit? That could require hearing protection, reduce exposure noise. There are some mathematical expressions for LEQ and LEX. LEQ is 10 times logarithm to the sum of Ti divided by 10 times 10 raised to Li divided by 10. And LEX is almost the same. Here is big T 8. So they are common, they are familiar expression terms, and the last one can be written in another way. Small ti duration of activity, E in hours. Le sound level of activity measured in dBA. Big T is a summation of Ti, total time, sum of all activity durations. Okay, then EX is 85 dBs. Example of reduced exposure, 8-hour shift. Then the LEQ is the same as LEX of that would say 85 dB. 4-hour shift. Then half time, and that makes a double of the sound pressure. That means 88 dBA. 2 hours shift. Is 1/4 of the hours. That means 6 increase. 6 dBs increase from the 85. That is 91 dBs. Note, legal limits are vary around the world. LEQ measured in classrooms. Singing, percussion, recorder and band, they are more than 85 dB. Only keyboard is a little bit lower. How long can teachers be exposed and still be safe? We can calculate. Yeah. Yes. We can calculate this using the formulas. Consequences of conductive loss by definition implies increased audiometric threshold. Transfer function of outer or middle ear is linear. Loss is linear. Superthreshold procession is normal. Deformation loss of pinna potentially reduce spatial hearing. We have a normal hearing of threshold of hearing, and we have a speech area it's upper than this, music and audible area, and then threshold of discomfort. And then we have some hearing loss, reduced dynamical range. That means that the impaired threshold of hearing is bigger than normal threshold of hearing. Consequences of sensorineural hearing loss: audibility, perception of loudness, masking and frequency, selectivity, temporal resolution, spatial hearing, and speech intelligibility. That was it. That was part 2. Thank you.